All right, we're going to finish up Chapter 2, Section 1, the second half. We're calling Part 2. You just spent some time solving equations. I see I've written the word equations twice. You don't get an extra point for that one. You have solved equations that have a single solution, which is like x equals 2 or something of that nature. Equations may also have infinitely many solutions or no solution. So an equation that is true for all values of the variable, if you get something like x equals x, or even if you end up with something like 2 equals 2, something equals something, it's called an identity. And what we can write for an answer for that is a big R. An equation that has no solutions, so when you get something equals something else, and it's obviously not true because 3 does not equal 5, it's called a contradiction because there are no values that make it true. So when you get a contradiction, you say a 0 with a line through it, which means empty set. So our first example, solve 3v minus 9 minus 4v equals a negative outside of 5 plus v. So let's go ahead and solve this. First we have to distribute our negative. So we get 3v minus 9 minus 4v. I'm doing this in many steps. Negative 5 minus v. Now let's collect like terms. We have lots of v's and some constants. So 3v minus 4v is negative v. Keep that 9 there. Okay, we need to add v to both sides. And we get negative 9. So those cancel out. Those cancel out. Negative 9 equals negative 5. But hey, negative 9 can't equal negative 5, so our answer is no solution. It's a contradiction. Let's try another one. Okay, distribute your 2. Minus 12, negative 5x. I just distributed the 2 to everything inside the parentheses. Now let's collect like terms. I have x's, so 2x over here. Negative 5x plus 7x gives me 2x. Okay. Move our variable over. Those cancel, and I'm left with negative 12 equals negative 12. That's true, but where'd my variable go? I need a variable to have an answer, and I don't have any variables left. Therefore, this is called an identity. And the answer we need to write is this one, all real numbers. Anything you plug in to x for this equation, anything at all that you plug in for x, you will get a true statement. Okay? So if I plugged in 1 for x, let's just test that. We'll pick a different color. I'm plugging in 1 for x. Okay? Turn your head sideways a little bit. That gives me 2. 1 minus 6 is negative 5 equals negative 5 minus 12 plus 7. All right, 2 times negative 5 is negative 10. Negative 5 minus 12 plus 7. Let's see. That is negative 10. So I just plugged in x equals 1 and I get another identity. If I plugged in x equals 2, I get another identity. X equals 0. It doesn't matter what I plug in for x. I get all real numbers as an answer. Okay, you try this one. push pause and go ahead and try it. So here's the solution. I end up with negative 30 equals negative 18, which is not true. Therefore, it's an empty set. Contradiction. Another you try. Go ahead and push pause. Try it on your own and then check the answer. And here, I distributed my 3. I distributed the 3. I distributed the negative 2, which gives me negative 2x plus 6. And I end up with an answer. 6 does equal 6, but my variable is gone. I don't have any solution. So no matter what I plug in for x, anything under the sun, I will get the answer. All right, one more thing. An inequality is a statement that compares two expressions by using the symbols, hold on, less than or equal to, greater than or equal to. Okay, those are the symbols that we're using for inequalities. We also can use not equal to. The graph of an inequality is the solution set, which is, very importantly, the answer. They like to make things fancy and say solution set. The set of all points on the number line that make the inequality true. So we would have a number line. Okay, if you had a solution of x is greater than 0, greater than or equal to 0, that means that your solution, which I'm going to graphically, can be anything greater than 0. It can be 1, 2, 3, 4, 5, 6, 7, on and on and on. So when solving an inequality, all properties are the same as equalities, except multiplication and division. That means when you're going about solving something, you're adding and subtracting, and everything is the same except you have a greater than or less than sign instead of an equal sign. But if you do multiplication and division with a negative, you must reverse the inequality symbol. Okay, must, and I'll give you a few examples. Oh, here's the proof of y. So let's just look at this. So the statement 4 is less than 6. You all say, yep, got it. All right, what's new? If I multiply negative 2 by both sides, you see I have flipped the inequality. It went from less than to greater than because I multiplied by negative number. So that gives us negative 8 is greater than negative 12. Okay, so if we graphed it, it would be negative 8 is bigger than negative 12. Okay, makes sense. 4 is smaller than 6, and negative 8 is bigger than negative 12. If you look at a number line, it's backwards because it's negative. The closer you are to the 0, the bigger you are. The further you are away from the 0, the smaller you are. Another example. Again, 4 is less than 6. Yes, what's new? Now let's divide both sides by a negative number. We flip the inequality. It went from less than to greater than. 4 divided by negative 2 is negative 2. 6 divided by negative 2 is negative 3. Our inequality switched because negative 2 is bigger than negative 3. And if you look at the number line, this is closer to 0, so it's bigger. This is further away, it's smaller. So let's try an example. Solve and graph. Okay, we have to get x by itself or isolate it. Subtract 4 from both sides. I'm left with 9x less than 12x minus 15. Subtract 12x from both sides. And I'm left with 9 minus 12 is negative 3x less than negative 15. Now I'm dividing by negative. Alarm should be going off. I flip my inequality. X is now greater than 5. If I'm graphing it, always put your answer in the middle. Put a few above it, a few below it. This is greater than, right there, greater than. And you guys all know that means open dot, arrow going to the right. Let's try another one. Solve and graph. Subtract 4x from both sides. I get negative 3x plus 8. Subtract 8 from both sides. Negative 3x greater than or equal to 9. Divide by negative 3. There's those alarms again. We know that x, flip your inequality, is less than or equal to negative 3. And graph. Negative 3 goes in the middle. And it's a closed dot because it's less than or equal to, and we graph to the left. You try. Last slide, last example. Push pause and try it on your own. And there's your answer. That's it. We are done with Chapter 2, Section 1, and you'll get your daily check in your classwork in the morning. Again, if you found any mistakes, sorry, I don't do it on purpose. And I do not go back and rewatch the whole video because I can't re-record it anyway. So just make a note on your daily check and you'll get a bonus point. I appreciate you looking so hard.